we're going to do today is go through just a basic look at parameters and design variations, and just kind of show how to use parameters to drive the size of a part, and then how to use the design variation as kind of a wrapper around the parameters, to give it a little easier UI to kind of make for an example, a family of parts. We're going to just make these little base plates today that change size and update parametrically. So just to get started here, I'm going to start a new sketch in the scene and just throw a rectangle out here, and then I'll put a circle in the middle of it. And the first thing I'm going to do is go ahead and dimension it. Oops, thought I had the dimension command hit there. There we go. Put some constraint dimensions on here. Position the hole, put a radius on the hole, and one thing you'll notice is that my horizontal and vertical came up pre-locked. By default that doesn't happen, but if you right click in here and you go to constraint, you can set up some automatic constraints, and I like the horizontal, vertical, and the tangent on. Typically if I'm drawing some sketch and I draw a horizontal line, I typically want it to stay horizontal, so that I turn these two on. The other ones are optional as well, but you can play with that. There's some other things that warnings if it's over constrained. Ask what you want to do with failed projected associations, things like that. And then the last thing we got to do to totally lock this down is to lock a corner, and I'm going to right click here at the origin and say lock position, and you see the profile turned green there. That means it's fully constrained. And then at this point I can... What's that?
Was there a visual when you went to that corner to indicate for sure that that was the point that was being recognized? I didn't see that.
No, it's just the hand cursor going over it. The points don't really light up, but if you have a little hand over it, that means you've got a point, and you can right click. Yeah, but there is just the little hand icon is really tells you. And then you can see, like here, I've got it. The cursor shows a line next to it. Here, the cursor shows a circle next to it, and then for a point, it just shows a little hand.
Okay.
Okay. So you can double-click these parameter dimensions and put in values that you want. I'm going to go ahead and just start doing that here and get the sizes that I want. Actually, I want that just to be 5. And set that to 1. All right, so I got the parameters where I want, but I want to relate them to each other. I'm going to put this down in the corner just so you can see it. When I right-click in the background, now I'm going to go to parameters, and this will bring up the parameter table. So every dimension that I created is now a parameter in the parameter table, which is really makes it handy for creating relationships between the various parameters. So for instance, I want the width of this thing always to be half of the length, so I can come over here and say PD1 is the dimension that is the width, so I'll put in, this will be PD2 divided by 2, in that field, PD2 divided by 2 there, and that'll set that locked. And you see it changed the dimension to kind of a brownish color. That means it's, it's got an expression on it, so it's relative to some other parameter. And let's see, this one also will be, so the circle is always halfway along the length. Put in that PD2 divided by 2. This one will be half the width, so it'll be PD1 divided by 2. And then the radius, I always want it to be 1/5 of the width, so I'll put in PD1. Just got to miss that last click there. PD1 divided by 5. All right. So now what you'll see is I can start changing the values here. If I change the overall length to 5, see the whole sketch updated. Okay, so we'll finish that. Go ahead, and I could have just started this as an extrusion, but that's okay. We can extrude it now. And I'll make that 1. All right. So we got that there, and when you you select these, you can see the dimensions. When you select the IntelliShape, you see the dimensions, and you can actually double-click and drive this from right here. And this could be as far as you go with it if you wanted to, but we can go further and create some more. Well, we'll create a few more parameters, and then I'll show you how to create a design variation based around that. Another cool feature is being able to kind of create parameters on the fly with the blend command. So what I can do is I can come in here, start the blend command, and I can say, okay, B equals 1. And so then I will go ahead and create, that's a little bit too large. Let's say, actually that'll be fine, okay. B equals 1, and when I hit OK now, I go back into the parameter table, select the show all parameters below the shape. You can see B is equal to 1. And I can say that that one is going to be my PD1 divided by 5. And hit apply, and it'll update that blend accordingly there. There we go. So now again, when I go in here and I update the overall length, see now the radius got larger, the circle got larger, and the whole plate got larger as well. So now to put kind of a wrapper around this whole thing and to give a better catalog, a drag and drop interface for this set of parameters that I've created, what I want to do is I first need to create an overall part parameter that will show up in the design variation interface. So this is kind of the tricky part of it. I've got all my parameters in place now that I need, but they're all in the shape level. I need something at the part level that will actually fill out in the design variation dialog. And that's kind of a confusing thing to me, but it's the way the software is designed, so it's just something we have to get used to. So you take the part, select the part, right-click the part, and go into parameters. Then you'll be at the part level in the parameter table, and you click Add Param, and I'm just going to call this OL for overall length, and I'll put it in as 5 for now, and I'll hit OK. And you see I'll have my at the part level, I'll say instead of at the profile or shape level, I now have a part level parameter that's 5, and then this overall PD2 dimension, which is our overall length, I can just use its expression field to put in OL, and then now this part level parameter will drive the whole thing. So hit apply and OK there, and that's all good. So I select the part now. One other thing I want to do is I want to control the thickness of this plate, and that gets a little trickier because we don't have any profile dimension that will gauge the thickness, so we have to go to a size box dimension. So what I'm going to do is I'm going to go in here to the parameter. I'm selecting it at the shape level, right-clicking and going to parameters, and now I'll be at the shape level, and I can add a parameter here, and I'll say maybe thickness for that, and And I'll start that out at, go ahead and start that out at 1, and hit OK. And now what I have to do is I have to tie this thickness parameter into the size box of height field. So I right-click on this IntelliShape again, and I go to IntelliShape Properties, and I go to Size Box, and I click on Show Formulas, and this will allow me to put in that parameter name in there, and then that parameter will always be tied to the height of the part. So if I go in here now to parameters and I change the thickness to be, change that to say 2, hit apply, you can see the thickness increases. I'll set it back to 1. Okay. And now again, if I want to drive this by the design variation, I need an overall part parameter. So I go select part again, so I'm at the part level, and hit add parameter, and I'll call this, I'll just go PD for part thickness, put in at 1. So this thickness will always be PT. Okay. Oh, it threw a 2 on there. It'll throw numbers on when it thinks it needs a numeric value in there. Oh, I think I see what's going on here. PT. What's that?
What happened to the original extrusion? That obviously you gave it some thickness at some point to get it that thick. Where is that dimension?
That's what's in the size box. That shows up in the size box here under at the IntelliShape level. You see the size box here. This is the height here, and if you show a formula, you can see that it's changed to that thickness value. And
you couldn't reference that thickness somewhere?
Well, I can reference it here in the parameter table. See, and this is where I can see. So what I did is I created a parameter that I then put into the size box table that we saw before in the IntelliShape properties. So now if I change the parameter here, the thickness will change. But all these other parameters are created by dimensions, profile dimensions, so they're just the length and width values, basically, not the height. And I can go ahead in here, and I'm not sure why it's not letting me. Oh, there it did. Now it did it. Okay. So yeah, so PT2 is the part level parameter that's going to show up then in the design variation once we get to it here. That'll let us control the thickness.
Hey, Kevin.
Yeah.
When you're at the very base level, can't you just select that little arrow there in the middle? When you're at the
in the parameter table?
No, not the part table, but at the shape level.
Oh, right here?
Can't you grab that little?
Yeah, you can grab the handle. And you can edit it that way.
Just making sure we could. That's all.
But yeah, if you do that now and you did that edit change, it's gonna give you a warning. Say this was tied to a parameter. Do you really want to do this? But yeah, you can always go back to the handles. But the idea of this lesson is just to show how to use the parameters.
So, but you can't put the parameter as you grab that handle.
Right. No, you can't. You can't put a parameter in here. No.
Got it. Okay, that's what I wanted to clarify. And you have to go to the size box.
Right. You have to go into the size box. Yeah.
Mm.
And that's where let me kind of reiterate that. Go into IntelliShape Properties, and you go to Size Box, and click Show Formulas. And that will let you type in the parameter that you created in the parameter table, so that shape's height always knows to go back to the parameter table for its value, and it's looking for the parameter THK.
And what has ultimate authority? If you use the size box handle to stretch it, will it override the parameters?
You can break the expression, yeah, and it'll warn you that you're about to do it, but it'll let you break it, yeah. Which I think is the best way to go, because that way it gives the user a warning and a way to opt out, but still lets them edit if they want to. So,
right.
Yeah, there's,
okay.
Yeah. All right, so we'll go on and create the design variation. Now I go over here to add-ins and click add, select the part first, then click add design variation, and then we'll click edit design variation, and it brings up the design variation dialog here, and I'm going to rename this first one because I'll just call that 5 because it's 5 inches long. And then I'm going to add a variation, and you can see it's got our two parameters in, the overall length and the part thickness. So I'll add one, call it design 10, and I'm going to change this to 10 inches long, and I'll change the value of the thickness to 2. I'll say apply, and maybe I'll change the color of the part too. And then I can generate a preview of that, which is kind of nice. I can go back to design 5 and generate a preview for that. We can kind of see them as we go through. So you can see it'll give you the different values, and then I can I'll add a third one. Call that design 20. Say this is 20 inches long, and we'll say the thickness is 3. And we'll apply that. Maybe give it another color. Make that one red. Generate that guy. All right, now we've got our design variation set and created. So we can come in here now, and we can right-click on the part and just go to the different design variations and just toggle them. So you can see how the thickness is changing, the radius is changing, the part is enlarging, and the hole stays centered. And so this is a real simple example, but it just kind of shows the power of creating a family of parts. And the nice thing about this is if you make a catalog now, you can drop this little guy in here, and whenever you drop it out, it'll prompt you, which design do you want. You can just pick them from the tab, and you can see the previews of them. You can go through. There's the preview zooms up, so it doesn't look a whole lot different, I suppose. I suppose eventually we could enhance this to have some actual the dimensions on the preview would be nice. We'll hit apply there, and we get the larger of the 3 variations. But then again, you can always come back and change that up. So in a nutshell, that's the basics of parameters and design variations. Is there any questions on that? That was a little brief, but it's kind of a lot of material to digest at one point. Any questions?
I'll look forward to seeing the video on this so I can go over it again.
Go over it again, yeah. This is one that takes some practice going over. As a matter of fact, Monday I went through this several times for myself just to refresh all the certain points.
And also you can do these in assemblies also.
Absolutely, yeah. You can combine those with assemblies and mate and align constraints, and so that when the size of one part changes, other parts move. For instance, if I had another part on here that was mated together, absolutely, the design variations will work alongside with other constraints. We just put one together here. So if I constrain this with this, okay, and then this face, say, with this face.
You know what? I think we should have a lesson in constraining too.
Yeah. I'll tell you what. Next time we'll do constraints. Because 3D constraints are definitely tricky. I mean, I got myself mixed up. I did an align instead of a mate. And it's an easy mistake to make when you're going through these, and you just miss a click.
I've been so confused on that sometimes, not knowing what to do.
Yeah, no, absolutely. That's a good idea, Joe. I'll set that up. So you can see the constraints keep it locked together through the different sizes. But yeah, we'll do a good example of 3D constraints, assembly constraints, basically. So.